Okay, hi everybody. My name is Stanislav Rumega. I've been officially in the S of this group for like 20 years, maybe. This thing that I'm gonna present is like a really small thing, but I just came up with this idea recently. I've been literally debugging this utility as of today, so it's not like by any chance ready, but I wanted to share it anyways because it's kind of looks like a fresh perspective, nothing fancy. Yeah, some of you may know that I did sort of fancy architectures like LabHSM toolkit, which basically was actor model implementation, but backed with hierarchical state machines long before not only LView or P state chart toolkit or yeah, let alone the actor framework. So Aloha, well, everybody and his brother now currently implementing actor-based frameworks. So you can actually make one just out of a simple cute message handler. Indeed, they are all based on it, but there are some nuances people still miss up to this day, like good state handling, not as an afterthought state handling. But this is not about that. So why I mentioned, because who the heck I am. I also, the previous thing was built on scripting. I also got involved with scripting very early. And no, and I didn't give it to us like with free will. It was the community that actually forced their hand. If somebody doesn't know, so when it's by accident it got public in 7.0, but then they tried to hide it. So why I was mentioning it, because I made PMS assistant at that point, which basically returned access to scripting to private methods and properties that allowed the scripting things. And then it was Jim Crink who actually convinced them, but much later on. So scripting is very important. And well, it's a shame, and I was hiding it for so long, but now we have it for like many years. So what else we can do with this? Let me show. This is like something maybe could be using, maybe somebody already did it themselves. So VI, right? Originally, the idea apparently was front panel is user interface, block diagram is code. But the user is supposed to see the front panel. The front panel has controls and indicators, right? Which are represented on block diagram as terminals. And that is naturally the fastest way of reading directly from controls and writing to controls or indicators through the terminals. So, but of course the code got much more complicated. Everybody uses sub-VIs, and nowadays, like, people actually use multi-actor systems where a single dedicated actor or multiple dedicated actors are playing the role of UI, but which have their own logic for quite extensive and complicated block diagrams. So when you need to display something on those UIs, you send messages to these actors, and then they would process them and output it finally to the same terminals, right? But, so are there any shortcuts? Sometimes I don't want to go through all that, right? So, sometimes, even in those complicated message handling actors, you need more freedom of juggling the actions around based on state, and that some of them involve writing to terminals, which means you have to literally have a wire somewhere out getting to that terminal to output the value or read most likely output. Now, but can we do it like this? So this is one VI and this is another VI, and can we just wire whatever our data straight to something which represents directly a terminal in another VI? Well, of course we can, but there are caveats, and not in all not in all cases, unfortunately. But that's let's go on. So why we need it, I told you. So direct access enhances system flexibility, enabling sub-VIs to adapt their behavior, by the way. If we look the other way, why would sub-VIs need direct access to controls of the VIs that call them? Based on current state and its controls, sub-VIs can modify their behavior too, right? It's not only about outputting to top-level VI indicators. So again, it's easy to do from within VI itself, but not so easy even from its sub-VI, direct sub-VI. You have to jump through hoops. So the most common one everybody knows is, of course, I don't know how much that can be seen, but you can pass a reference to the control, right? And then you write to the value property of that reference, and which is incredibly slow. So long story short, I made this kind of benchmark like 6 years ago. I know nobody can see anything there, but the point is that the fastest way to write to control an indicator, and some of you know about that from another VI, is to use set control values by index or get control value by index functions, which were introduced in 2013, long time ago. So there is this good article by LabVIEW Craftsman blog, and it explains why they're so much faster. I'll just read you. It's a long text. Why setting control indicator values is slow when you do it through that property node? Because when you set the value property, LabVIEW simulates a user changing the value of the control, stopping the execution thread, switching to the user interface thread to change the value. Then LabVIEW updates the operation buffer that stores data at the control and withdraws the control if the front panel is open. LabVIEW then sends the data back to the execution thread in a protected area of memory called the transfer buffer. LabVIEW then switches back to execution thread. The next time the execution thread reads from the control, LabVIEW finds the data in the transfer buffer and receives the new value for the execution buffer that stores data on the block diagram. So this guy made his own benchmarking, and he found that based on my benchmarking, it turned out that updating control on the front panel with a local variable takes about 1.5 times longer than wiring directly to the terminal. A value property node, and he was trying to even from the same VI, takes about 2,750 times longer than wiring to the terminal. And the set control values by index node takes about just 3.75 times longer than wiring to the terminal direct. So when wiring directly to the terminal, LabVIEW copies the data from its original memory location to the memory location of the control, meaning there is only one copy operation when it does it with the terminal within the same VI. So, and the set control values by index function, they also require only one such copy operation. So he has some benchmarks here. So it's really fast, much faster. So, okay, so we know they're faster. We know that, yeah, we would like to use them. Why not everybody is using them so much? Hide? Okay, so that, yeah. Okay. So you see, okay, I don't know what you see from that distance, I wouldn't, but write to terminal is 40 nanoseconds in his measurement, local variable 60 nanoseconds, set control value by index 150 nanoseconds, yeah, longer, but property node 0.011 millisecond, 0.1 millisecond. Okay, so thousands of times. Now, so when they introduced it, and I said, use these functions to get or set control values faster than is possible with other VI server objects. I would say any, as to best of my knowledge, such as the value property in the control class. You can use these functions to get or set control values almost as fast as when you're wired directly from control terminal. However, these functions require more advanced application design than other methods for getting and setting control values. That's the catch. So ultimate speed, but more wires, apparently it has at least 2 inputs. So VI reference and the index itself. So it is quite challenging to use them as is. You have to pull a lot of wires around. And then the first thing comes to mind, index fragility. So you remove add controls on front panel of that VI to which you're referring with these functions somewhere in sub-VI, and maybe many controls in many places. What happens? Their index changes on that VI that you're going to write to or read from. So that's called index fragility. So apparently that's no good for your development. And the second thing is, well, you still need the reference to that VI, to the controls of which or indicators of which you want to write. So you have to pass that. You have to pass that around all the way to these functions. So that, of course, leads to bugs, performance, inefficient code maintenance. Due to index-based access can lead to performance degradation of LabVIEW applications over time. Now, I decided, okay, what the heck? Can we simplify that for ourselves? I mean, everything is done out of laziness, right? So, but you still have to work a little bit before exercising that. So let's do this. Let's make this utility, right? Which would create this access RVIs, basically API to your target VI. So you have a target VI, right, with some controls. You want to write to them or read from them somewhere in the sub-VIs that it calls. Why don't we just, well, and we want to use this control, set control and get control values by index functions, but they require indices and reference to the VI. What can we do? So what if we just wrap that call, just that function call, and say index constant value, and maybe even VI reference into a single VI, make it inline for the fastest work. So, and then you, from index-based reference system, you instantaneously get into name-based reference system, back to just like you would do with that, you would still refer by name to those controls in indicators and by name to that of the VI, where they are located. So basically, and we can put them all together in the file name of that VI. VI1, control 1, set. VI3, control 5, get. And then while developing, they would still have the indices, right, as constants. They may need to be updated. So why not have a utility that would be watching your target VI, and as soon as you do something with its controls, rearrange them, change order, delete, and then a lot of controls automatically change their index, right? So, and then it would update these accessors, access VIs, with the correct number, correct reference, correct data type of the control. You may change the data type of the control itself, right? And then, boom, you have both convenience and the speed of that those functions provide. So, so scripting allows us to do what? So say the very top one, right? The simplest one. Why there have to be some different types? Because what you can do when you're both your say caller and callee are non-reentrant may not work when your say caller is reentrant. So the simplest case is both VIs are non-reentrant, right? All we need to have is a static VI reference to that target VI where the control is located, right? And then the index, of course, and then the corresponding data. So that data control that goes in, of course, should be of that type. So let me switch to that LabVIEW and show you. So on the right, you see this. You can possibly you would want to run it as a tool, put it into a project folder, but I haven't tried that yet. So remember that first picture. We have one VI that has nothing but say indicator and a call to another VI. So this is exactly what you saw. So what do you think if I click this, run this one VI, VI1, what's going to happen? Boom. You see? No fancy wiring. Just as if you're wiring into the terminal of that other VI. Isn't that cool? Now, of course, there is a caveat that thing is not really a terminal, right? It is a VI. And I cannot get its block diagram. It's somewhere deep. Oh, there it is. Right? But it already existed. So, how does the utility work? So this is the VI1 is the target VI, right? When we click on it, so I'm catching VI activation, VI deactivation, and selection change events, right? So that we don't have to scan, overload LabVIEW and stuff. That is tricky because the application itself is a VI, So when you just click on it, it will deactivate that one, activate this one. So that I hope the logic would be like much easier, but unfortunately it hasn't. So that's why I has been debugging up to like this afternoon. So anyways, but look how it is. So how easy it is. So imagine we didn't have this. And I even delete this here. Delete. Nothing. So all we have is a VI1 that is calling VI2, and there are two indicators. Nothing there. Now, all it takes to make that communication work. So I click on a control in that target VI. You see it shows up here. So I create. So there are several types of these accessors VIs that you can do. But when this, with the simplest case of two VIs both not being non-reentrant, it's enough to have just this static VI reference. So you see, one click And I have that VI. So I just open it, and I just drag it here. Boom, you're done. Well, now, let's get something more complicated. So I wanted, well, actually, we can do it here too, but I would rather show you other examples. So I will close this. This example is a little bit more complicated, has a numeric. So, but the idea is the same. Do I want to run it? Oh, it's really hard. The resolution of this screen is not so, it's very small. I mean, it's good for presentation, but so again, two VIs running. Now they're running in a loop, right? So nothing there, just, you know, indicator on the side. This one is basically the same. So now, but I have this button here, so I click send, that gets sent, okay? So just one more use case. Now here we have numerics. And a little bit of benchmarking built in. Okay, nothing fancy. So here, this bottom one is just the sub-VI of the top one. So I just ran it, it ran the sub-VI. So 400,000 values, it took only 200ths of a second to actually write them. And because this is the sender, and send them to the top level VI. And I cannot find it. There it is. Nothing fancy. Well, it would be also rosy, right? If it hadn't been for some pitfalls. That static VI reference is really convenient, right? But it won't work if, say, your calling VI is just a clone, right? It would, it doesn't matter if it's the sub-VI it calls is a clone or not, but the name changes. You cannot use a static VI reference to access the controls of that clone. So the best we can do is, it's an overhead, but it's only one overhead. We can find the reference to that caller, open it, and from that first iteration on, you already will have it to the correct VI. So, which means you can still get away without wiring the VI reference into this accessor. Just only data, just like in the first case. Let me show it. So we have this reentrant launcher. So VI7 itself is nothing funny. It's everything as in previous example, but it's just reentrant. So we would need a launcher, right, to launch it to produce a clone. So we'll close it for now. And so let's do that. So I also made it sub-VI reentrant, right? But it doesn't matter. It could be non-reentrant. The point is that the caller has now this name that you cannot, in the general case, predict, and you shouldn't. But how do we get the reference to it? I'll show you in a moment, but first let's see if it works, right? So I click send to VI7. So what the hell is inside? So we'll close the clones. VI7, nothing fancy. Now VI8 has this guy. And this guy is a little bit more complicated than in the case when you have non-reentrant VIs and you can get away with a static reference. So, but at most you run this code in the error case only the very first time. From there on, you have the correct VI reference in that shift register, and everything is this just as the same as it was in the case of the static VI reference. Now, all good, but as I mentioned, index fragility, you might want to replace even the type of the control that you're referring to, let alone its order, right? Let alone its index can change. So how does this utility handle that? Let's see. So I will close this, guys. So big guy. I already created a bunch of access, so multiple controls. For example, you see this numeric 5 has index 1 here, right? So, and numeric 4 has index 0. Now, if I remove numeric 4 temporarily, it will ask me if I want to delete the corresponding, the utility watches, you see, and it asks me if I want to delete the corresponding accessor method, because yeah, I'm deleting a control which I already have accessor method defined. Let's say I don't want to delete. It actually has multiple of them for that particular one. But anyways, the point is, now numeric 5 becomes 0. And for some reason, Control Z doesn't work. What? What? Control Z doesn't work. How come? Yeah, I understand, but I don't see the revert there. So I know what revert does. Actually, if you already have the accessor method created, you can still push that create button, and it will recreate it while VI is still in memory. LabVIEW doesn't like it, but we can just write to a temp file when we find that it is already in memory, and then just do a revert. I wanted to show you these cool things, but I guess it has to wait. So let me see. So we have a lot of already defined accessors for numeric 5, right? So I already this one with a lot of controls on purpose already also has a sub-VI, right? So I wanted you to show how cool it is. It changes. So, okay, numeric 11 is this, but it gets it. So a little bit in the opposite direction. So as you can see, main one, this sub-VI of main one has this numeric 11, right? But we want to get control value from the caller to the sub-VI. So for which we can use a get accessor method using the get function. Why didn't So get functions are a little more complicated, but still doable. So let's note this is a main one non-reentry numeric 5 get D. D stands for dynamic VI reference. So we are trying to read from numeric 5 control on main one. Now, what would happen if, so it's currently 0, right? But we did something, we added controls, or we actually did set tab in order and assigned this control to be 0. No, it didn't work. What did work? Okay, now this, so I changed the tab in order, you see? Now this guy becomes number 3. Now look here. Do you see that? There is 3 there now, and that constant. Okay? Now, what if I decide that this should not be a double? Say I want it to be 132. Did you notice the change? So the icon, the data output itself, the data indicator, and the data type that we need here, both all changed. I can change it back to double so that you know this. Got it? So unfortunately, the only events I figured that I could catch are VI deactivation, VI activation, VI deactivation, and selection change. Well, I also then additionally have to filter them on whether it's a valid VI activation, valid VI deactivation, and whether it really selected controls, because that event will be fired even when you select something on block diagram, for example. So again, it turned out to be much more complicated logic that I had to implement than I initially thought. But the point is, it works, right? Now, let me go back to presentation. No, that's not what I wanted. Outlook. Ah, there. You won't believe me, but this is my very first presentation in a group, and I'm 57 years old, and I'm the only presentations I did, last one I was during interviews. You have to tell about yourself, so you would show this. So one-click creation I covered. So there are those buttons. So there are many buttons there that well, not many, but 6, right? So why there are 6 buttons here? So get and set with static VI reference you can create, get and set with dynamic VI reference, and well, for the cases that you cannot get away without a reference being passed to it, you can create with an VI reference input. And that will look very simple. If I can get this block diagram somewhere. There. So there you go. So in which case you would still want VI reference? Well, when I assume when you launch your VI sub-VIs dynamically. So, or in any other fancy case where then you have to pass this VI reference number in. But the utility will still watch the control index. It will still modify the data accordingly to the type. When you modify the target, it's on the target VI front panel, everything stayed the same. So what you can think of is, what if I want from this successor to actually not look up, but look down, right? But then, okay, what the tree goes down, the branches go down, so then there can ambiguities there. But you can still use like all VIs in memory, for example, function, and come up with other fancy ways and create different templates which would have, similar to that dynamic one, a way to obtain VI reference without the need to be for it to be directly wired in. Okay. Just finished this today, so I sorry, couldn't do all of that. But so I'm not. It's definitely not ready for prime time. But at least you get the idea, right? And we create this inline VIs. We just which compiler just inserts in there with that call to those very fast functions, and boom, you're from a sub VI. You are writing as if you were writing, as if it looked to you as a developer, just as if you were writing to that terminal in another VI. That's the biggest value. And it will take care of maintaining the indices. So you get, this gets around that index fragility problem. And in some cases, not in all, around the need to wire the target VI reference in, to pull it around your application somehow, pass it around and stuff. So what else I have left? I'm sorry, I maybe. See, I'm not a good presenter. Sorry about that. I'm a big pain in the ass to ask questions, but by myself, I'm not that good. So I will post this. Actually, there is it's online already. I will just post the link. They gave me a link on OneDrive that anybody can watch this PowerPoint without even PowerPoint. So two big features to summarize. I'm finishing. One-click creation of such accessor VIs and automatic updates to fragile parts of the VI. Data type, well, the index being the main one, data type, and of the control, and the data type constant if we're doing a get. So conclusion, AI made it. So just for the breaking, so the utility revolutionizes. I didn't write this. So I just gave it a topic for presentation, and it gave me this kind of, template, which I had to modify, of course. So I wouldn't say it revolutionizes index-based cross-VI control access in LabVIEW, but maybe somebody will think that it does. So apparently enhancing performance. Performance of whom? Of what? Well, first of all, your code, right? If you still doing that right, if you still are doing those writes, you need to write. But then, as your developer, in terms of your development time, it improves your performance because it handles all this stuff for you. So, provides developers with a powerful tool, enhancing their capabilities to create efficient and effective applications. Just blah blah blah, but that's what I want to finish. Thank you very much. Any questions? Yes, John, be pain in my ass.
First, you mentioned that the PowerPoint slide will be available. Will the code be available?
Do you guys want it already? Even if it's not ready and ugly?
Yeah, it looks really cool.
And what? Sorry, what was the last?
I said that it looks really cool.
I was just curious, with the benchmarking you did you compare?
Can you speak
the-
louder, please, John?
Sorry, there we go. So when you did the benchmarking on the different methods of accessing, did you by any chance benchmark using a user event to send the data?
Yes.
And
Yes.
where did
So
that
all
fall?
those DQMH fans out there, it's slower than the queues. Slower. Forget about it. Not only inconvenient, but slower. Let me open that. So, it's like I currently work on the screen with my. This is very simple benchmarking. First of all, it has to be sequential, right? So all different ways. So where do I have the key events?
I see it there in the middle,
It's there, right?
right about halfway down the screen.
Yeah. So I made it 6 years ago. This kind of little benchmark. So everybody laughed at me. And I will read the comment I put here, and the stick and finger. I will read it. It's small. Run this VI. Wait, it will take a minute for 100,000 iterations in each sender. Watch the numbers in each indicator. Study the block diagram to make sure your conclusions. Where was I saying that? Oh, here. Yes, and the number 4. Make your own conclusions regarding which ones you want to use to communicate between loops and VIs, which run in parallel to each other, including all sorts of messaging architectures, and wherever you need to pass data between VIs asynchronously. For example, update indicators in one VI from within another when working with LVOP actor framework, DQMH, etc.
And then the second question I had is, does your current code handle complex controls like a cluster of controls?
Remember that big one? Let me show you. I made sure. So not only one of the things very important. Remember, in the same VI, the fastest write is to a terminal. So when the controls are complex, although you can get references to individual controls, say within cluster, it still is a single terminal. So when I do selection here, this utility will find the first one going up, which has a terminal. So if I select a subcontrol of a cluster, right, it will still show that it's control 1, the whole thing, right? Now, let me show you something. So control 1, do I have control 1? Yes, very simple. So let's use the simplest one. Where is it? Where is the block diagram of that guy, huh? There it is, right? And so you see this data control here. Let's look at front panel of that accessor now. So you go your merry way around and you modify this control in your target VI, this complex one. Say you delete this boolean. Did you see what happened? It automatically updated that complex data type in the accessor VI. If Control Z works, we can go around. But it doesn't. I don't know. So if Control Z worked, that would show up back on
Right.
both.
So you're writing to the entire cluster from the accessor, not to the individual elements of it.
Because this has a terminal.
Right.
We're looking not into controls. We're looking into writing into terminals, but in another VI. And that's how it works. It doesn't work other way. Yes, you can still write into individual subcontrol using a reference, right? But that's painfully slow, as everybody knows.
So if you did want to write to an individual piece of the cluster, for some reason, you're going to have that penalty still.
It's not possible. Just like it is not possible in the sense you would have to copy everything else, right? Forget about sub-VI. You have one VI, you have this indicator, right? Which is complex. How do you write to that individual subcontrol of that?
So it's the function you're using, the by index function doesn't give you access to controls.
It doesn't give access to controls which are parts of which don't have terminals.
Got it.
It is explicitly stated somewhere.
Okay.
In LabVIEW documentation. I didn't make this up.
Yeah. Okay. Thanks.
So I guess what that guy, you could read that presentation later. I quoted, and you can actually read that entire article. I gave a link about this function about these functions. He explains I actually read that, but I understand that it's not very understandable by me reading it. But you can carefully read it. You will understand. Somehow it is more direct way. Those so basically those functions write not to controls. They are called set control values by index, right? But in reality, they write to the terminals. Just like and that's the biggest advantage. Okay.
I think the reason your Control Z isn't working is because your scripting is doing stuff after you perform your last action.
I like those T-shirts. It works on my machine. So, but let's see if I stop it.
Do we have any questions online? No. Okay.
No, it doesn't work either. If I stop.
Yeah, if you are online, please type your questions in. We have people looking at the chat. So,
okay, give me a break, guys. This is my first ever presentation in the group.
You're doing fine.
Okay, thank you very much. Hopefully, somebody will find it useful.